Hello and welcome back to Lyndall Brakes. Today we're going to be talking about our One-Piece Enforcer rotors. These are made out of low carbon martensitic steel. This is CNC machined in the US. You know, we incur a lot of cost for the heat treatment that goes into our stainless steel. For that reason, we don't want to stress that heat treat by cutting out of a laser or EDMing the part. So we utilize a diamond carbide end mill to cut this, and we creep up on our dimensions very carefully, slowly. We use a lot of cooling. So we don't generate the temperatures in the manufacturing process that most manufacturers do when they laser cut. So that's one thing to note. Again, you'll notice this design is a very narrow bandwidth, and it's scalloped ID and OD, and I want to talk about that. So for a fixed amount of clamping force at the caliper, we've reduced the surface area as compared to stock to increase the surface pressure. So you can see that compared to stock, we have less material substantially, and therefore our pad is less buoyant. When you place, you can see how much of the friction material is actually contacting the rotor. So for a fixed amount of clamping force, where it's grabbing is going to be much more pressure than if the hydraulic pressure was spread over the entire surface area of the mold as it is in the factory rotor, as you can see. So we've reduced the surface area to increase the surface pressure. Additionally, these scallops on the ID and the OD allow for much more surface area for cooling to take place. Additionally, it allows for radial growth to take place without impinging. So when a rotor gets hot, when it reaches thermal saturation, it's going to grow radially up to 200 thousandths of an inch, almost a quarter of an inch. That's quite a lot. So when it does, it's not going to grow in parallel unless the thermal coefficient of expansion is uniform. That's another nice feature of this design by Harley, is that they've attached the rotor where the caliper's grabbing the rotor. So your thermal coefficient of expansion is very uniform because you're heating up all of its very narrow bandwidth so it all reaches the same temperature evenly, as opposed to having a solid one piece that bolts at a hub register, and down here in the center you're hooked to a heat sink, which keeps the thermal coefficient of expansion very low, while out here in the outer bandwidth your thermal coefficient of expansion is very high. So on a molecular level it gets the material excited, and it's not going to grow flat and parallel. It's just not. Especially if you've stamped it or cut it with a laser cutting or EDM device. Another reason that we creep up on our dimensions is to keep this rotor as stable as possible under a high thermal load. Okay, so we've talked about the premium material, low carbon martensitic steel. So now we're going to put this on the factory wheel. This is a factory wheel. Honorable mention to Joe at Willie Shiny. You can go to at Willie Shiny on Instagram or willieshiny.com, and he does the impeccable refinishing on factory wheels. He did this chrome, he did this powder coat, and it's absolutely stunning. So I'm going to take this rotor off the wheel. We've removed this rotor, obviously. There's only two fasteners holding it. And when we did so, as an extra measure of precaution, we took a hand tap and we cleaned out the threads. We cleaned out all of the Loctite, the dried Loctite that was in the threads. So now we can run our fastener down very nicely by hand, and additionally, more importantly, when we go to torque it, our torque specs will be accurate, because if you leave the dried Loctite on the threads and you go to run your fastener down, you're going to get a false torque reading. So you can see ours compared to stock. Ours is about 30% lighter. Additionally, there's a good illustration of the reduction in surface area for the increase in surface pressure. So I'm going to take this off. I'm going to put this boat anchor right here. I want to show you real quick while I have these, our fastener versus theirs. So theirs is a steel fastener. All 5 of our fasteners weigh the same amount as this one stack. So this is 6AL 4V titanium. It's machined here in the US on a Swiss screw machine, as good as it gets. This is not titanium, this is US made titanium. So I'm going to install this on the factory wheel. You can see this just takes a moment, and it's a pleasurable experience when you've properly chased the threads and cleaned that out. You can run them down with your fingers, and again, you can ensure that your attachment and your torque readings are as accurate as can be. Now we have installed our one-piece enforcer rotors on the factory enforcer wheel for a substantial upgrade in performance and looks. Again, we have the factory rotor as compared, factory fastener as compared. We also offer these fasteners in black as well as the rotor in black, so everything goes together if you want to murder it out. While I have this wheel up here, real quick, I want to talk about this fastening mechanism, because many times, as you know, the rotor fastens down here on the axle, and now we see it attached up here on the wheel. And the reason this is a superior design is because we're actually attaching the rotor where we're grabbing the rotor, as illustrated. So we're clamping onto the rotor here, and we're fastened right here. So there's no deflection. You've taken away all of the leverage for deflection. Additionally, energy from the braking event is now going to be absorbed by the wheel, and it isolates the axle from the equation. What's good about this is when you isolate the axle from the braking event and the energy induced in the braking event, you will keep the energy in the forks and the alignment of the forks and the calipers to the rotor much more precise, especially during hard braking events. So this is a brilliant design. I believe this is another Brembo patent that's expired, and now you'll see it on BMWs, Harley Davidsons, Hondas. We do some of our aftermarket wheels in this manner as well. Our Hard Star is a isolated hub design, a lot more intricate, but it's worth the effort because the performance is superior to a hub-mounted rotor. So I want to show you, we have, if you want to go for an oversized brake, we have these two-piece design, goes up to 13-inch. So if you want to put your aftermarket caliper on here, you can see it's going to work fine, and it's a lot bigger brake. It's a two-piece rotor, so it floats like this. Our full floating lug drive carrier mechanism, which you've seen in our prior videos, I believe. So here I can peel this ring out, and I can pull the center section out. You see it floats. It floats much like a clutch basket on this carrier center. We put the helical retaining clip to the ID, so the faster you go, the more this ring expands and locks into place. You can hear it's full floating, and then additionally, when you install it on these pins and put the fastener in, it can float on these pins. So it's a double floating rotor, if you will. Bit of overkill, but that's what we're all about here. Anyway, I think that covers it. We talked about the stock Harley rotor versus our one-piece enforcer. Also, one side note, if you don't know, our rotors have 2 guarantees. All of our products have 2 guarantees, rotors and pads. If you put this on your bike and you're less in love with it for any reason, we'll buy it right back. If you run this rotor with our pads and you don't go metal to metal, we guarantee this disc against warpage for the life of the bike. No other company offers that, and that's how much confidence we have in our materials and our manufacturing processes. This friction coupling has taken us 25 years to develop, and we're super proud of it, and I believe you will be too. Thank you for joining us today. If you like this video, please click the like and follow, and we'll see you next time.